And we're back. It's time to sort it out once again. We have motion on incline. We have a cart given an initial velocity. We know the angle of the ramp. We know little g. And our task is to find the distance that the cart will travel along the ramp, as well as the time it takes to do that. So, begin with the free body diagram. The sum of forces along the ramp would simply be F sub g parallel. So write a net force expression for that. Plug in mg sine theta. Notice that the mass cancels, and the acceleration would be given by g sine theta. Then, next, let's look at the distance along the ramp. For this, let's use this kinematics equation. Then the final velocity will be 0 when the cart comes to rest at its farthest point up the ramp. So plug in 0 for that. Now remember, the acceleration is going to have to be negative if the initial velocity is positive. So let's go with that reference frame. Then plug that in, rearrange a little bit, solve. Then we can plug in what we found for the acceleration above. We can plug it in right here, and this would give us the distance traveled along the ramp. That is not, of course, straight horizontally in this situation. That would be, we're considering along the ramp here to be the x-axis. Then let's find the time. We have the cart moving with an initial velocity. We also know it's going to be accelerating. So of course, the initial velocity is positive and the acceleration is negative, so use your signs in this way. Then we have to think, how long would it take for that initial velocity to decrease to 0? And the expression shown here would give you that. So that's what you need to turn your screen green.